Building codes exist to establish minimum safety standards that protect people and property from hazards such as fire, structural collapse, and electrical shock. They ensure a consistent level of safety and functionality across buildings and structures. Codes promote energy efficiency, water conservation, and accessibility, which can improve the overall performance of buildings. Adhering to codes is often required by law to ensure compliance with building regulations and avoid legal liability. By following codes, architects, engineers, and contractors can reduce their risk of being held liable for safety issues. Some argue that codes can be overly prescriptive and stifle innovation, preventing the use of new and potentially safer building materials and methods. Meeting code requirements can add significant costs to construction projects, potentially making it more difficult for individuals and businesses to build new structures. The approval process for code-compliant designs can be lengthy and complex, causing delays and increasing project costs. In some cases, following codes can lead to unintended hazards, such as creating barriers for people with disabilities or making structures less resistant to certain types of hazards. The debate surrounding the potential hazards of building codes is a complex one with valid arguments on both sides. While codes are essential for ensuring public safety and consistency, it is important to consider their potential drawbacks as well. Striking a balance between safety and flexibility is crucial to ensure that codes continue to serve their intended purpose without creating unnecessary hazards or hindering innovation. The primary argument for the necessity of codes is public safety. Codes establish minimum safety standards aimed at protecting individuals and their property from various hazards. These hazards can include fire, structural collapses, and electrical shocks. Without these codes, there would be a significantly higher risk of accidents and injuries within buildings. Consistency is another key benefit. Codes ensure that a consistent level of safety and functionality is maintained across different buildings and structures. This standardization simplifies design, construction, and inspection processes. It also ensures that regardless of location, buildings meet a certain baseline of quality and safety. Furthermore, codes contribute to building efficiency. They often incorporate provisions promoting energy efficiency, water conservation, and accessibility. These features improve the overall performance of buildings, reducing their environmental impact and enhancing their usability for all occupants. Legal compliance is a critical aspect. Adhering to building codes is typically mandated by law. Compliance with these regulations is essential to avoid legal liabilities and ensure that buildings meet the necessary standards for safety and quality. For architects, engineers, and contractors, following codes reduces their liability. By adhering to established standards, they minimize the risk of being held responsible for safety-related issues that may arise during or after construction. Despite these advantages, there are arguments against the potential hazards of codes. Some argue that codes can be overly prescriptive. This can stifle innovation by restricting the use of new and potentially safer building materials and methods. The strict adherence to existing codes may discourage experimentation and the adoption of more effective solutions. Costly compliance is another concern. Meeting code requirements often adds significant costs to construction projects. These costs can make it more challenging for individuals and businesses to undertake new construction or renovations. The financial burden can be particularly problematic for smaller projects or those in economically disadvantaged areas. Delays and inefficiency can also occur. The approval process for designs that comply with building codes can be lengthy and complex. This can lead to delays in project timelines and increased overall costs. The bureaucratic nature of the approval process can sometimes hinder progress and create unnecessary obstacles. Unintended consequences represent another area of concern. In certain instances, strict adherence to codes can lead to unintended hazards. For example, codes may inadvertently create barriers for people with disabilities or make structures less resistant to specific types of hazards. These unintended consequences highlight the need for careful consideration and flexibility in the application of building codes. A balanced approach is necessary when evaluating the role of building codes. While they are essential for ensuring public safety and consistency, their potential drawbacks must also be acknowledged. It is crucial to strike a balance between safety and flexibility to ensure that codes continue to serve their intended purpose without creating unnecessary hazards or hindering innovation. This involves regularly reviewing and updating codes to incorporate new technologies and address emerging challenges. It also requires a willingness to consider alternative solutions that may not strictly adhere to the letter of the code but still meet or exceed the intended safety standards. The ongoing debate surrounding building codes reflects the complex interplay between safety, innovation, and cost. By carefully considering all perspectives and striving for a balanced approach, we can ensure that codes continue to promote safe, efficient, and sustainable buildings for future generations. Codes, in general, establish minimum requirements and standards for building design, construction, and maintenance to ensure public safety and welfare. The debate arises because, in certain situations, strict adherence to specific code provisions might inadvertently create or exacerbate hazards. This can occur due to several factors. Firstly, codes may not always keep pace with technological advancements and innovative building practices. When codes are overly prescriptive, they can stifle the adoption of newer, potentially safer materials or methods that are not explicitly addressed in the code. Secondly, codes are often developed based on general principles and may not adequately address the unique conditions or specific risks associated with every building project. The one-size-fits-all approach can sometimes lead to unintended consequences, where compliance with the code results in a less safe outcome than a more tailored design. Thirdly, codes can be complex and open to interpretation, leading to inconsistencies in enforcement and potential errors in application. This can result in situations where the code is followed incorrectly, creating hazards that could have been avoided. Fourthly, codes may sometimes prioritize certain safety aspects over others, leading to trade-offs that could increase the risk of other types of hazards. For example, energy efficiency requirements might lead to tighter building envelopes, which can reduce natural ventilation and increase the risk of indoor air quality problems. Consider an example of fire safety codes requiring fire-resistant doors and walls to compartmentalize a building, preventing the rapid spread of fire. While this is generally a good practice, it could also create barriers that impede evacuation in the event of an emergency, particularly for people with disabilities. This is why codes often include provisions for emergency exits and accessibility, but the potential for unintended consequences always exists. Another example might be in seismic design. Codes often require buildings to be designed to withstand a certain level of earthquake shaking. However, simply making a building stronger may not always be the best approach. In some cases, it could lead to a more brittle structure that is more likely to collapse in a severe earthquake. Alternative approaches, such as base isolation or energy dissipation devices, may be more effective in protecting the building and its occupants, but these methods may not always be explicitly covered by the code. This statement that following codes can cause a hazard is not meant to suggest that codes are inherently dangerous or should be disregarded. Instead, it highlights the importance of exercising engineering judgment and critical thinking when applying codes. Engineers and architects have a responsibility to go beyond simply meeting the minimum requirements of the code and to consider the specific circumstances of each project. They should identify potential hazards that may not be adequately addressed by the code and develop solutions that mitigate those risks. This might involve using alternative design approaches, incorporating additional safety measures, or seeking exceptions from the code when appropriate. Furthermore, the statement underscores the need for ongoing review and improvement of codes. As new technologies emerge and our understanding of building performance evolves, codes must be updated to reflect the latest knowledge and best practices. This requires collaboration among code developers, engineers, architects, contractors, and other stakeholders to ensure that codes are comprehensive, practical, and effective in promoting public safety. The reason why this is stated despite the primary goal of codes being safety is likely related to several factors, including legal liability, the desire to encourage innovation, and the recognition that no code can anticipate every possible scenario. From a legal perspective, stating that following codes can cause a hazard may serve to limit the liability of code developers and enforcing agencies. By acknowledging that codes are not foolproof and that engineers and architects must exercise professional judgment, these organizations can reduce the risk of being sued for damages resulting from code-compliant designs that nevertheless fail or cause harm. Encouraging innovation is another important consideration. By acknowledging the limitations of codes, authorities can encourage engineers and architects to think creatively and develop solutions that go beyond the minimum requirements. This can lead to the development of new technologies and building practices that ultimately improve safety and performance. Finally, the recognition that no code can anticipate every possible scenario is a key factor. Building codes are necessarily general in nature and cannot address every specific risk or condition that might arise in a building project. By acknowledging this limitation, authorities can emphasize the importance of professional judgment and encourage engineers and architects to tailor their designs to the specific needs of each project. The potential for codes to create hazards is not an argument against the existence of codes, but rather a call for a more nuanced and thoughtful approach to their application. Code should be seen as a starting point, not an end point, in the design process. Engineers and architects must use their expertise and judgment to ensure that buildings are not only code compliant, but also safe, durable, and sustainable. This requires a commitment to continuous learning, a willingness to challenge conventional wisdom, and a deep understanding of the principles of building science and engineering. A performance-based approach to building codes represents an alternative to the traditional prescriptive approach. Prescriptive codes specify exactly how a building must be designed and constructed, while performance-based codes set out specific performance objectives that the building must achieve. A performance-based approach offers greater flexibility and allows engineers and architects to use innovative design solutions to meet the code's objectives. It also encourages a more holistic approach to building design, where all aspects of the building's performance are considered. The use of risk assessment tools can also help to identify potential hazards that may not be adequately addressed by the code. Risk assessment involves systematically evaluating the likelihood and consequences of different types of failures or hazards. This information can then be used to develop strategies for mitigating those risks. Risk assessment can be particularly useful in identifying unintended consequences of code compliance and in developing alternative design solutions that reduce overall risk. Education and training are essential for ensuring that engineers, architects, contractors, and code officials have the knowledge and skills necessary to apply codes effectively. This includes training on the principles of building science, the use of risk assessment tools, and the application of performance-based codes. Continuing education is also important for keeping professionals up to date on the latest changes in codes and technology. Open communication and collaboration among all stakeholders are essential for improving the effectiveness of building codes. This includes creating opportunities for engineers, architects, contractors, code officials, and the public to provide feedback on the codes and to participate in the code development process. Open communication can help to identify potential problems with the codes and to develop solutions that are practical and effective. In conclusion, while building codes are essential for ensuring public safety, it is important to recognize that they are not foolproof and that strict adherence to the code can sometimes create hazards. By exercising engineering judgment, using risk assessment tools, and promoting open communication and collaboration, we can improve the effectiveness of building codes and ensure that buildings are safe, durable, and sustainable. It is a complex issue involving a balancing act between standardization, innovation, and site-specific considerations. The key takeaway is that codes provide a baseline for safety, but they should not be considered a substitute for sound engineering judgment and a thorough understanding of the specific risks associated with each project. The code development process is often influenced by various factors, including industry interests, political considerations, and public input. This can sometimes lead to compromises that may not fully address all safety concerns. Therefore, it is important for engineers and architects to remain vigilant and to advocate for codes that are based on sound scientific principles and best practices. Moreover, The enforcement of building codes can vary widely depending on the jurisdiction. In some areas, code enforcement is rigorous and thorough, while in others it may be lax or inconsistent. This can create disparities in the level of safety provided by buildings in different locations. Therefore, it is important to ensure that code enforcement is adequately funded and staffed, and that code officials are properly trained and qualified. The use of technology can also play a role in improving the effectiveness of building codes. Building information modeling, for example, can be used to create detailed three-dimensional models of buildings that can be used to identify potential code compliance issues. Virtual reality and augmented reality can also be used to train code officials and to simulate emergency scenarios. The potential for codes to create hazards is not limited to the design and construction phases of a building's life cycle. Codes can also have an impact on the operation and maintenance of buildings. For example, fire safety codes may require regular inspections and maintenance of fire protection systems. Failure to comply with these requirements can increase the risk of fire. Similarly, energy efficiency codes may require regular maintenance of heating and cooling systems. Failure to comply with these requirements can lead to increased energy consumption and higher utility bills. The concept of resilience is becoming increasingly important in building design. Resilience refers to the ability of a building to withstand and recover from a variety of hazards, including natural disasters, terrorist attacks, and other disruptions. Codes are beginning to incorporate resilience measures, but there is still much work to be done in this area. Resilience measures can include designing buildings to withstand extreme weather events, providing backup power systems, and developing emergency response plans. The design and construction of sustainable buildings is another area of growing importance. Sustainable buildings are designed to minimize their environmental impact and to provide a healthy and comfortable indoor environment for occupants. Codes are beginning to incorporate sustainability measures, but there is still much debate about how to best balance sustainability with other building performance objectives, such as safety and affordability. The integration of smart building technologies is also transforming the way buildings are designed, constructed, and operated. Smart building technologies can be used to automate building systems, to monitor building performance, and to provide occupants with real-time information about their environment. Codes are beginning to address smart building technologies, but there are many challenges associated with ensuring that these technologies are safe, secure, and reliable. The use of alternative materials and construction methods is also becoming more common. Alternative materials, such as bamboo and recycled plastic, can offer environmental benefits compared to traditional materials. Alternative construction methods, such as modular construction and 3D printing, can offer cost and time savings. Codes are beginning to address alternative materials and construction methods, but there are many challenges associated with ensuring that these approaches are safe and durable. The performance of buildings is also affected by human factors, such as occupant behavior and maintenance practices. Codes cannot fully address human factors, but they can provide guidance on how to design buildings that are easy to operate and maintain and that encourage safe occupant behavior. The development and enforcement of building codes is a complex and challenging process. However, it is essential for ensuring that buildings are safe, durable, and sustainable. By exercising engineering judgment, using risk assessment tools, promoting open communication and collaboration, and keeping abreast of the latest technological advancements, we can improve the effectiveness of building codes and create a built environment that meets the needs of society. Codes provide a baseline for safety, but they should not be considered a substitute for sound engineering judgment and a thorough understanding of the specific risks associated with each project.